This is a video to review how to run a one-way between subjects ANOVA. This is a good comparison to use when comparing 3 or more groups at a time. So before with t-tests, you're only able to compare 2 groups at a time. This allows you more pieces of information. So here we have an example with a variable called type and a variable called hours. If we scroll down to variable view and we look at what those mean, we see that type stands for the type of entertainment, and our values tell us that 1 stands for regular TV, 2 stands for cable TV, 3 stands for Netflix. So it seems that there are 3 different ways of watching programs. Then we have a dependent variable of hours. This is known as the hours spent watching. So this is a self-reported measure of how many hours each type of user spends watching some type of program using that type of entertainment. So we want to compare how people who have regular TV versus cable versus Netflix, how much time each of those types of users spend using those types of entertainment. So to run the ANOVA, we'll go to Analyze, General Linear Model, Univariate. We'll move our hours to our dependent variable, and we'll use type of entertainment as a fixed factor. So factor is also where your independent variables go. With a one-way, you'll just have one factor with multiple levels, and that reflects the 3 different groups, or possibly you could have more. Alright, we'll also go to options. So here we have an opportunity to get the estimated marginal means, which is how we find out how those 3 separate levels will differ from each other. So we'll move overall over and type, and then we'll choose compare main effects, and we use the Bonferroni post hoc tests to find those differences. We also click descriptive statistics and estimates of effect size. And then here is where you would change your significance level. Let's say if you had a hypothesis that had an alpha set at 0.01, here you would want to change that so that you get a 99% confidence interval, for example. We'll leave this as is for now. Alright, everything should be selected, so we'll go ahead and run the analysis. And you should get an output that looks like this. So there are a lot more boxes than with the t-tests, but you can always extend this left-hand side menu. It shows the menu or a map or a pathway of what all the different boxes are. And the main one that we're going to pay attention to here are the tests of between subjects effects. So again, they're between subjects because you can't have crossover in this study with Netflix, cable, or regular TV. Here is type. This is our factor that we're interested in. Here are the degrees of freedom for type, and we would report type and error. So you would start off by writing F parenthesis 2, 57, and then close your parenthesis. Then if we scroll over here, we've got our F statistic, which is 36.425. You'd round that to 0.43 for your APA write-up. And then here we have our p-value. So our p-value is less than 0.05, so it is significant. In fact, it's even smaller than that. It's less than 0.001, so that's what you would write in your write-up. Alright, so how do we know who spent more hours watching TV or watching programs? Well, we'll go over here to this pairwise comparisons box, and this will tell us where the significant differences occur. So here we have the mean hours spent watching for each group, but just because these numbers are different might not mean that they are significantly different, so we have to double check. So if we use our pairwise comparisons box and we start with a value here on the left, so regular TV, and we compare with one of the items here on the right, so let's start with cable, we'll scroll over to the significance level box and we see a significant difference between regular TV and cable. So what does that mean? That means that this about 4 hours for regular TV is significantly lower than the cable hours, which is about 11 hours spent watching. So there is a significant difference between regular TV and cable. Same thing goes for regular TV and Netflix, as we have a significant difference here. So this 3.7 is significantly different than this 12.4. So we see those significant differences. And then this value and this value are just the same comparisons that we just talked about. They're still comparing regular TV to Netflix and regular TV to cable. They're just flipped. You can see these mean differences are the same numbers as these mean differences. We're just changing the direction. The one comparison we haven't talked about yet is cable and Netflix. So if we compare cable to Netflix, we see there is no significant difference between cable and Netflix because the p-value is greater than 0.05. So what does that mean? Well, that means that even though this 10.95 and this 12.4 are numerically different, there's no statistical significant difference between these two types of entertainment. So cable viewers spend about the same amount of time as Netflix viewers using their respective entertainment source. So all we really see here is that regular TV is less than cable and regular TV is less than Netflix. Alright, so that was the one way between subjects ANOVA.